Okay, good. Now we are live. Yes, we are live. OK， 大家新年快乐 ，Happy New Year, everyone. Nah, there's no viewer, so yeah, I'm talking to air, but it's fine. I'm talking to the future of myself, which is pretty amazing.
Now, as long as they add up to 12,
Okay. Okay, so now it's fine.
don't all need to be the same size. So for example, if I only wanted 3 columns instead of 4, I could get rid of the 4th column by deleting those rows, and maybe change the 2nd column. Instead of being a column of size 3, let's make it a column of size 6. So there's a length 6 column instead. And now if I refresh the page, now suddenly I see 3 columns where the middle one is twice as large as the ones on either end. And as I shrink this down, I can see that it shrinks down as well. And one of the advantages of using bootstrap columns is that they too can be mobile responsive. They too can wrap around to other lines if they ever need to. So for example, let me pull up columns1.html. Here, for example, I have a row, and let's take a look at what's going on in here. Recall that every row in Bootstrap is divided up into 12 column units, but Bootstrap, in addition to letting me specify how many units a column should take up, also lets me specify how many units that column should take up depending on the size of the screen. So if I'm on a large screen, as indicated by LG, this is saying that on a large screen, this div should take up 3 units of space, and this div should also take up 3 units of space. And for each of these 4 divs on a large screen, each will take up 3 of the total 12 units of space, so they'll all show up on one row. What happens on a small screen, though? Well, here, call SM for column on a small screen. I've said on a small screen, each column should take up 6 units of space, 6 or half of the total 12 that I have in the row. And so I use up 6 here for a total of 12 in one row, which means the next 2, also size 6, need to go onto a second row. And Bootstrap is smart enough to do this math for me and figure out how exactly these elements should ultimately be laid out. So now if I open up columns1.html and see what's there, on a large screen, I see 4 columns all on the same row. But as I shrink down to a smaller screen eventually, we'll see that things change. I now see the 3rd and 4th sections move down onto the 2nd row, because on a smaller screen now, when the window is smaller, now I only have the ability to show 2 elements in any particular row. So I get 2 on the 1st row, and then 2 on the row underneath that. So all in all, there are a lot of different ways now that we can use CSS in order to make sure our pages are mobile responsive. We can use Bootstrap's column model to make sure that columns move around whenever the size of the window shrinks or grows. We can also use things like Flexbox and the grid model, writing our own CSS to make sure that our page is responsive depending on the size of the screen that the user happens to be using in order to visit our web page. So these are some of the very powerful features that we get using just CSS. But one thing you might imagine is that as we begin to write more and more CSS, there's going to be more and more repetition, things that appear again and again and again. And we've already seen some ways that we can minimize redundancy in CSS. We've seen how we can move CSS into the style section of our web page. We've even seen how we can move CSS to an entirely different file. However, what we haven't yet seen is how to deal with other types of redundancy. And so let's take a look at an example of that now. Let's imagine, for example, that I want to style multiple different elements in different ways, but using some common properties. So for example, let me create a new file that I'll in this case call variables.html, and you'll see why in a moment. I'll go ahead and copy hello.html, but I'll get rid of all this bootstrap inside of it. Let's imagine that here I have maybe 2 lists, an ordered list and an unordered list, where my unordered list has unordered item, maybe 3 unordered items, and my ordered list also has 3 ordered items. Again, just for sake of demonstration, I'm showing that we have these 2 lists now. And I'll open up variables.html just to give you a sense for what that could look like. We have 3 unordered items in an unordered list, 3 ordered items in an ordered list. Let's imagine I wanted to style these a little bit differently. Maybe inside the style section of my page, I want to style the unordered list to have a font size of 14 pixels and maybe a color of red. And my ordered list, I would like that to have a font size of maybe larger, 18 pixels, but also a color of red. I want to keep the same color for all the text, but I want the font sizes to be different. Now if I refresh this page, here's what I see. They are indeed of different sizes. The ordered list items are larger than the unordered list items, and they're all red, but there was some redundancy, some repetition that was introduced when I was writing my CSS code. In particular, when I was writing my CSS code, I've repeated this usage of the color red. If I ever want to change the color from red to blue, for example, I'm going to have to change my code in 2 different places. Ultimately, I just like for my CSS to be a little bit more powerful. And so that brings us to our last topic today, which is a language called Sass. And Sass is a language that is essentially an extension to CSS. It adds additional features to what CSS has to offer, just to make it a little bit more powerful for us to be able to use and manipulate CSS in a way that's going to be faster and remove some of the repetition that we might have had in CSS previously. And one of the key features of Sass is the ability to have variables. So let's take a look at an example of this now. I'm going to create a new file. Normally, when we created our CSS files, we call them like variables.css, something .css to stand for a CSS file. Sass is a different language, though, so it's going to require a different extension. We're going to conventionally use .scss to stand for this is a Sass file. So here's now variables.scss. And now what I can do in Sass is I can actually create variables in the same way that we could create variables in a programming language like Python, which we'll soon see. CSS normally doesn't support variables, but Sass is going to give us that power. In Sass, all variables begin with a $sign, so I can create a variable, $color, to create a variable called color. And I can say the variable called color is going to be equal to red. So this line here, line 1, is my way of telling Sass I'd like to create a variable called color, and I'd like for its value to be red. And now I can add the same styling I had before. I can just use normal CSS and say for an unordered list, I'd like a font size to be 14 pixels. But the color, instead of saying red here, I can use the name of a variable. I can say $color to mean go ahead and use the value of the variable color as the color for this unordered list. Then for an ordered list, I'll also say font size 18 pixels and say color should also be this variable called color. By using a variable, I've removed the repetition. Rather than having the word red show up in multiple places in my code where I would need to change it twice if I ever needed to change it, now I have defined the variable once, and I only ever need to change it in one place if I ever need to make modifications to this particular file. So now let's try and link this file. Instead of, we'll go back to variables.html. Instead of putting the style code here, I'll go ahead and link a style sheet and say the href should be variables.scss, because that's the file where my styling exists. So now let me try and open up variables.html after I've linked the CSS. And all right, something seems not quite right. I specified font sizes, I specified that everything should be red, but it's not showing up. Everything is showing up black, and I don't see any of the differences in sizing. And the reason for this is, while the web browser, things like Chrome and Safari and Firefox, can understand CSS, they can't by default understand SCSS or Sass. Sass is an extension to CSS that web browsers don't understand out of the box. So in order to solve this problem, once we've written our Sass file, we need to compile it, convert it, translate it, so to speak, from Sass into plain old CSS so that our browser is able to understand it. And so you'll need to, in order to do this, you'll need to install a program called Sass onto your computer. You can install it on Mac or PC or Linux. And now in the terminal, in order to do this compilation, I'm going to say Sass variables.scss, the file I'd like to compile, colon variables.css. So variables.scss is the file that I would like to compile, and the file I'd like to generate is variables.css. I'd like to turn my Sass file into a plain old CSS file. I'll go ahead and press return, and all right, that compilation process is now done. And so now, inside of variables.html, instead of referencing the SCSS file, I'm going to reference the CSS file as the style sheet. Because my web browser only understands CSS, it doesn't understand Sass. Now when I load the page, now I see the result I expect. Everything shows up as red, and the font sizes are different. So ultimately, this was a two-step process. I first needed to take my Sass code, compile it into CSS, and then I could link the CSS to this particular page. But the advantage now is that if ever I want to make some sort of change, I want to change the color, rather than change it in two places, or you might imagine in a more complex page, like tens or dozens of places, I just go to the SCSS file, and I change the color from red to blue. Now if I refresh the page, all right, everything is still red, and it's because I forgot a step. I changed the Sass file, but that doesn't automatically change the CSS file. I need to now recompile the CSS file by saying Sass variables.scss, variables.css, to compile the file again using the updated Sass file, and now I see the updated changes. And if you're curious as to what the updated file looks like, I can actually look at variables.css to see what code happens to be there, and though it's styled a little bit strangely, you can see that I have a UL with a font size of 14 and a color of blue, so they've substituted the word blue for this variable, and they've done the same thing for ordered lists as well. Now, in practice, it's going to be pretty annoying if I'm building a web page, using Sass, if I constantly need to go back and recompile my Sass into CSS every single time. What I'd like to do is just automate that process, and Sass makes it easy to do this. I can just say Sass -- watch variables.scss, variables.css. And what that's going to do is now you see Sass is watching for changes. Sass is going to monitor the variables.scss file. And if ever I change my Sass file, Sass is going to know about it, and it's automatically going to recompile the corresponding CSS file. And you can do this not just with single files, but entire directories as well if you have multiple different Sass files. So now what I can do is if in the variables.scss file, I change the color. Instead of blue, I now want it to be green, for example. I now save the variables.scss file. And now, without doing anything, take a look at my terminal. Sass detected a change to variables.scss, so it gave me a new version of my original CSS file. If I go back to my web browser now, refresh the page, now all of the text is green, as I would expect it to be. So that's one of the very powerful features that Sass gives us. It gives us the ability to add variables to our CSS code just to factor out commonalities. If there are common fonts, common colors, common borders, common styling that I want to apply to a lot of different things, it becomes much easier just to use Sass in order to do so. And finally, we'll take a look at a couple of other features that Sass gives us the ability to do. One of them is the ability to nest CSS selectors inside of other CSS selectors. So one thing you've seen so far, for example, is that in CSS, if I wanted to style all of the unordered lists that are inside of divs, for example, I could say like div arrow unordered list in order to style unordered lists that are inside of divs. What Sass will do is it'll give us a bit of a nicer syntax for doing this type of thing, in particular by allowing us to nest CSS inside of other pieces of CSS. So just as an example of this, I'll go ahead and open up a file I already brought called nesting.html. And so here's what we might see inside of nesting.html. Here's the body of the page. Inside the body of the page, I have a div, inside of which is a paragraph inside the div, and also a list, an unordered list or UL, that's inside of this div as well. And then we also have a paragraph that's outside of the div, and a list that's outside of the div in addition to that. So a number of different elements, some of which are located inside of other elements. And what I'd like to do is be very precise about how I style these pages. What Sass is going to allow us to do is it lets us write a Sass file that looks a little something like this. Let's take a look at what it's doing. It's saying, for the entire div, I would like to give that div a font size of 18 pixels. And then what CSS normally doesn't allow us to do, what we can do now using the power of Sass, is say, for any paragraphs that are inside of that div, go ahead and give those paragraphs a color of blue. And for any unordered lists that are inside of the div, give those unordered lists a color of green. By nesting these CSS selectors inside of others, we've been able to get across the idea that I only want to style the paragraph if it is inside of a div. And this is just a little bit of a nicer, cleaner syntax for doing some of these more complex styling tasks that might come up. So what does this actually look like? If I take this SCSS file, and turn it into normal CSS. What is the result going to be? Well, let's take a look. We can try it out by, let me go into my nesting folder where all these files are located. And if I run sass nesting.scss, turn it into nesting.css. Now let's open up nesting.css and see what it looks like. Here it's turned into take all of the divs, give them a font size of 18 pixels, and then we're using the same descendant selector notation that we saw before, where all the paragraphs inside of divs should be colored blue, all the unordered lists inside of a div should be colored green. And this certainly works, and we could have just written this CSS from the beginning, but it can be a little bit cleaner, a little bit easier to read, to use Sass in order to really say paragraphs inside of divs should be structured this way, unordered lists are styled in some other way, and using this nesting approach just makes it often easier to take a look at this SCSS page and really understand how all of the different style code interacts with each other. So after all of this now, if I open up nesting.html, you might see something that looks a little something like this. The paragraph inside the div and the list inside of the div, those both get changes to the way that they've been styled. But unlike them, these paragraphs outside of the div and the list that is also outside of the div, those get styled a little bit differently. So two features now we've seen inside of Sass. We've first seen the ability to have variables to make sure we're not repeating ourselves in many places throughout the code, and now we've seen the ability to nest CSS selectors inside of each other by taking advantage of Sass. And finally, we'll take a look at one last feature that Sass is going to give us, and that is something called inheritance. If we have certain CSS selectors that are related to other CSS selectors, but that are maybe adding some additional information. And in this case, I'm actually going to show you the finished product first. So let's go into inheritance, and let me open up inheritance.html. And here you see I've tried to almost implement Bootstrap style alert messages in HTML. I have a success message up at the top, a warning message, and then an error message. And each of these messages you'll notice are styled differently. In particular, they're each a different color. But despite that, they share a lot in common. They share a common border, they share a common font, they share a common size, and many other properties are all shared between these elements. There are just some things that are a little bit different about them. I could have written 3 different CSS selectors to deal with all of these cases, but there might be some repetition there. So here's what I can do by taking advantage of the features that Sass gives me. Let me go ahead and look at inheritance.scss to look at the code for doing this. And it looks a little bit cryptic at first, but here's what I've defined. I've here defined using a % sign that this is what a generic message is going to be, something that I can extend later to add additional information to. All of the messages, whether they be success messages or danger messages or warning messages, they're all going to have the same font, they're all going to have the same border, they're all going to have the same padding and margin spacing around and outside of it. But each of the specific messages are going to be slightly different. How are they different? Well, let's take a look down here. Anything with a class of success, I'm going to say extends this message. And by extends this message, what I mean is that anything with a class of success is going to inherit all of these CSS properties, the font, the border, the padding, and the margin. But it's going to add additional information to it. In particular, we're going to add a color. We're going to say that for success messages, the background color is going to be green. I've extended the basics of what a message is, but said that this message in particular has some additional style that we're going to assign to it as well. And the other two messages behave in very similar ways. My warning message extends the message, but instead says the background color should be orange. And finally, the error message also extends the message, but this time gives us a background color of red instead. So now when you compile this all together into inheritance.css, which I compiled in advance, this is what this is ultimately going to look like. It translates what I've written into saying, all right, success and warning and errors should have all of these properties, but success should also have this background color, warning should have this background color, error should have this background color. So again, we could have written this CSS. There's nothing that Sass does that we couldn't have written ourselves using CSS. Sass will just make it a little bit easier to do many of the same CSS. They're ultimately going background color. Is this message what I mean? Mean is that anything with a class of success is going to inherit all of these CSS properties, the font, the border, the padding, and the margin. But it's going to add additional information to it. In particular, we're going to add a color. We're going to say that for success messages, the background color is going to be green. I've extended the basics of what a message is, but said that this message in particular has some additional style that we're going to assign to it as well. And the other two messages behave in very similar ways. My warning message extends the message, but instead says the background color should be orange. And finally, the error message also extends the message, but this time gives us a background color of red instead. So now when you compile this all together into inheritance.css, which I compiled in advance, this is what this is ultimately going to look like. It translates what I've written into saying, all right, success and warning and errors should have all of these properties, but success should also have this background color, warning should have this background color, error should have this background color. So again, we could have written this CSS. There's nothing that Sass does that we couldn't have written ourselves using CSS. Sass will just make it a little bit easier to do many of the same things. We can write things in a little bit of a nicer syntax by saying the success message inherits from the message but adds a background color, and likewise the warning and error messages do the same thing, but in a simpler syntax and a bit of a nicer syntax, such that later we can let the computer take the Sass code and compile it into CSS instead. And so those now are some of the fundamentals of what we've seen in building web programs using HTML and CSS. We've seen how we can use HTML to describe the structure of our web page, deciding what's going to show up where on the page, and then we looked at CSS and how CSS can then be used to style our web page in various different ways, adding custom styling like colors and layouts, but also thinking about things like responsive design, like what happens on a mobile screen or on a tablet, and making sure that our web pages look good on those screens too. And then finally, we took a look at Sass, an extension to CSS that adds a number of additional features like variables and nesting and inheritance that make it even easier for us to be able to write style that we can apply to our web pages. From there, we're going to be transitioning now to looking at how we can use HTML and CSS in larger web applications as we begin to incorporate other tools like Python and JavaScript and other languages and frameworks altogether. So this is web programming with Python and JavaScript. We'll see you next time.
Okay, so now we have finished this one, HTML and CSS. Okay, so I think let's maybe do some coding. Why programming and okay, let's write some HTML.tab HTML. Okay, so let's see. See, we got hello world. Okay, so this is very simple. So let's do something else. This is heading 1. Heading 2. Okay, this is good. What are these? CSS. No, still not. Okay. What if I do this? What is G? see. We can get this down. Okay, so basically HTML and CSS can help us design our website and framework and website that we CSS front we need a backend. Okay. Yeah, so we do need a backend about that. A backend, I think it will be giving the second project 0. What is that? Huh. Okay. I don't want to do this next. CSS Git Python Django. Okay, I'm more interested in Django. Let's see.
Okay, welcome back, everyone, to Web Programming with Python and JavaScript. So thus far in the course, we've taken a look at a couple of different technologies. We took a look at HTML and CSS, which are languages we can use to describe the structure of a web page and then style it appropriately. And then we also took a look at Python, a programming language that we could use to get programming features like loops and conditions and variables and functions and more. And what we're going to do today is introduce Django, which is going to combine these two. Django is a Python web framework, which is going to allow us to write Python code that is able to dynamically generate HTML and CSS, ultimately allowing us to build a dynamic web application. So what is this now going to enable us to do that we weren't able to previously do using just HTML and CSS? Well, using HTML and CSS, the web pages that we created were static web pages. They were the same, and every time you visited the web page you were looking at was identical. But ultimately, if you think about websites you interact with on a day-to-day basis, say like the New York Times, for example, it's not the case that every time you go to the New York Times homepage, you're seeing the exact same HTML. It changes. The next day, you might see the new date. You might see the next day's articles. Whenever someone comments on an article, you can see those comments, and you can see how many people have commented on an article, for example. And it's probably not the case that someone is sitting there updating the HTML of the New York Times website every time something changes, but rather more likely, there is some program, maybe written in Python, maybe written in some other language, that is dynamically generating that HTML and CSS and allowing the web application to respond based on how users are interacting with it. And this is ultimately what we're going to be trying to create using this Django web framework. We're going to be creating software that's going to run on a web server such that clients running in their web browser can make requests to our web server, and our server is going to respond back with some sort of response. And so how does this process actually happen? Well, ultimately, it boils down to this protocol, HTTP, otherwise known as the Hypertext Transfer Protocol, which is the protocol for how messages are going to be sent back and forth over the internet. In this case, you can think about this as a computer, some user, which we might call the client, and then our server, which is going to be the server that is going to contain our web application. We are going to write a Django web application that is going to run on this server, and clients are going to make requests to that server. The server is going to process that request and then return some sort of response. That request might look a little something like this. Underneath the hood, it might start with the word get. Get is just an example of a request method, a way that you might try to get a page. So get just means I would like to get a particular page. In this case, the page I'm trying to get is the / page, just denoting the root of the website, usually the default page for the website. HTTP 1-1 is just the version of HTTP that we're using, and the host is what URL we're trying to access the web page for. So example.com or some other website, for example, that I might be trying to make a request to. So this request ultimately gets sent by my web browser when I type in a URL and press return, for example. The server processes that request and then gives back some sort of response. And the response will generally look a little something like this, beginning with the HTTP version 1.1, or in some cases version 2 now, and then some sort of response code. 200 is a response code that just means OK. Everything was OK. The page was returned successfully, for example. And here on the second line, we see content type text/HTML, which just means the format of the data that's coming back in this response is HTML data. It's HTML data that the user's web browser on the client should then render as HTML, for example. And there are other content types as well and other information that comes back in that response. But the key idea is just thinking about the web in terms of requests and responses. One user makes a request to get a particular web page, and what they get back is a response like this that hopefully includes status code 200, which means OK. But there are a number of other status codes as well. Some of the more popular, 200 means OK. You've probably seen 404, the status code that means not found if you try to request a web page that doesn't exist, for example. Others you might see are 301, moved permanently. That often happens if you're redirected from one website to another, for example. We'll take a look at an example of that shortly. 403 generally means forbidden. You're trying to access a page you're not supposed to have access to. And 500 usually refers to some sort of internal server error, usually meaning that whoever was writing the server, maybe our Django web application, has something that's buggy in it. And we might need to go back and figure out where that bug is in order to fix it. And again, there are other status codes as well, but these are some of the most common that we're going to be seeing and interacting with as we go about building web applications using Django. So Django is a web framework. It's a set of tools that is already built for us that's just going to make it easy to get started by writing Python code in order to design a fully fledged web application by taking care of some of the stuff that most web pages all have to do, such that we can focus on the interesting logic of building our own web applications. So the first step you'll need to do in order to use Django is to install it. If you're using Python, you may be familiar with pip, the Python package manager, which makes it easy to be able to install new packages. And the first thing we'll probably want to do is install Django. And here we're going to be using Python 3, so you might need to specify pip3 install Django to install Django on your system. And after you do, we can run a command to be able to create a Django project. And that command looks something like this: Django-admin start project, followed by the name of the project that we would like to create. When we run this command, Django is automatically going to create some starter files for us, just to get started with the process of building a web application. So let's try creating a project now. I'll go ahead and go into my terminal window. And what I'm going to do is type that command. I'm going to type Django-admin, and then start project. And then I need to give this project a name, and I'm just going to give this project a name of lecture 3, for example. You can name the project whatever you'd like. And when that happens, if I type ls, what I see is that a lecture 3 directory or folder has been created for me by Django. And if I go ahead and open this up inside of my text editor, we can take a look at what files are inside of this lecture 3 directory. So actually, I'll go ahead and cd into lecture 3 and open it up. And what we see inside of lecture 3 are a couple of files that we're given just to get started. So there are a couple of files, not all of them are really interesting to us right now. But first and foremost, manage.py is a file that Django is going to create for us. We'll generally not need to touch that file, but we're going to use the manage.py file to be able to execute commands on this Django project. And we'll see a couple of examples of that now, and a couple of examples of that in future lectures as well. And then the other important one that we'll be looking at is settings.py, which just contains important configuration settings for our Django application. Settings.py comes preloaded with a couple of default settings, but we might want to change those settings to be able to add features to our application as well, or make some modifications to how the application behaves. And then the other important file that's pre-created for us now here is urls.py. And you can think of urls.py as a sort of table of contents for our web application. That on any given web application on a website, there are a number of different URLs or routes that you can visit. On Google, for example, you can visit /search or /images. And urls.py is just going to be a table of contents of all of the URLs on my web application that I can ultimately visit. And so if I'd like to try running this web application just to see what it looks like, the way to do it in Django is in the terminal. I'll run Python manage.py followed by a command, and the command is called run server. And so this is generally how we'll use manage.py. We'll run manage.py followed by an argument specifying what command we would like to run. And Python manage.py run server means go ahead and actually run this web server. If I do this, I'm now running this web server locally, and I see a bunch of debugging output, but the interesting point to me is that it says down here, starting development server at http://127.001:8000. And so this is where my web application is currently running. 127.0.0.1 is an IP address, an address on the internet that just refers to my local computer, the computer I'm looking at right now. So only I can access this, not anyone else on the internet. And 8000 is what we would call a port number. It just refers to what type of service is being run, and you might have multiple different internet services running on different ports. In this case, our Django application is running on port 8000. So if I copy this URL and just go ahead and go into my web browser and paste that URL in, what I see is just Django's default page to say our installation of Django works, and this now is the default page that Django is going to give to us to say that Django has been loaded for this web application, and we can now actually start to begin building this web application by adding the features we want to it. And so what we've created here is what we call a Django project. And in terms of the way a Django project is structured, is that every Django project generally consists of one or more Django applications. So one project may have multiple applications within it. And the reason for this division is if you think about big websites, oftentimes a big website, a big project, has multiple different apps that are sort of separate services that operate within it. Google, for example, has Google Search, but also Google Images and Google News and Google Maps, where you can think of each of those individual services as a separate app all under one larger project, like Google, for example. Or Amazon's website, for instance, might be one big project that has a couple of different apps within it. One app for shopping, maybe, and one application for Amazon's video service, for example. And so Django comes preloaded with this ability to take a project and divide it into multiple distinct apps. Maybe for simpler apps, we're only going to have a project that has one app inside of it instead of multiple, but it has the ability to allow us to create these separate apps that have different capacities. So if we want to get started with Django, the first thing we'll need to do after we create a project is create a Django app. And so the way to do that, if we go back to the terminal, I'll go ahead and exit out of this server by pressing Control-C to say I would like to exit, stop running the server. So now if I go back to that URL and refresh it, it won't work because the Django server is no longer running. But I'll run the command python manage.py start app, and then the name of the app that I would like to create. And for our very first app, I'll just call this app hello, for example. So I've now created one Django project called Lecture 3, and inside of which I've created the very first app that I've now called hello. And so if we take a look at our files now, you'll see that in addition to a Lecture 3 directory, which existed before, and so Lecture 3, and inside of which I've created the very first app that I've now called hello. And so if we take a look at our files now, you'll see that in addition to a Lecture 3 directory, which existed before, we also now have a hello directory that Django created for us that is going to contain the information needed for the hello app to work. And there are a number of files, again, that are generated by default. We're not going to look at all of them today. We're going to focus primarily on views.py. We'll see why in a moment, which is going to be the file that lets us describe what it is the user sees when they visit a particular route, for example, where we can decide what gets rendered to the user. And the other files we'll take a look at over the course of this term, taking a look at what additional features Django has to offer. So we've now created this hello app that we would like to install into this project. And in order to install it, we need to go into the settings for this particular Django project. So if I go into the Lecture 3 directory and open up settings.py, what I'll see here is a big file all created for me by Django. I didn't write any of this code, but this is all just the default configuration for a Django project. And if you scroll down, somewhere there you'll see a variable called installed apps, which is where Django configures what apps are installed on this project. And there are a whole bunch of individual apps that are installed by default that are just created by Django. One, for example, manages sessions, which we'll take a look at a little bit later. But if I want to add my new app that I've just created called hello to these installed apps, I'll go ahead and just add to this list of strings, this installed apps variable, I'll just add hello. And so now hello is going to be an installed app on this particular Django project. So now what I'd like to do is actually make this app, this hello app, do something and display something when I try and visit a particular route, for example. So how can I go about doing that? Well, let's go ahead and go into the hello directory, and let's take a look at views.py inside of my hello app. So here's the default file I get for views.py. I see a comment that's given to me by default that says create your views here. And you can think of each view as something the user might want to see. So let's go ahead and just create a default view. And in order to create a view in Django, we're going to define a function. So this function, I'll just call index. This function, by convention, takes as argument a request argument. And this is going to be an argument that's going to represent the HTTP request that the user made in order to access our web server. So if we want information about that request, we can look inside of this request object to get access to some of that data. And we'll take a look at that momentarily, too. But now, what would I like for this request to do? Well, what I want to do for now is let's just do something simple and return an HTTP response of hello world, for example. Now, HTTP response is a special class created by Django. And so if I want to use it, I'll generally need to import it. And so Django is going to give us a lot of features that we might want to use in our web applications. But if we want to use them, we generally have to import them first. And it just so happens, and I only know this from reading Django's documentation, that I can include a line like this from django.http import HTTP response to say I would like to import the ability to give an HTTP response. And now what I have is a function representing my view. This function is called index. And what the index function does is it just returns an HTTP response of
拍张照。
那你泄露出去了，可以不行。
对。
在露点了不行。这样。屁股就是大，胯宽了，我都没有腰了，是吧？
等那个生完了，你还可以慢慢瘦回去。
其实也差不多，就长了个肚子哈。
对。
你看看，然后生完可能就50几。这是肉肉的屁股跟肉肉的大腿。
Hello world. And so this is the response, but now we need to tell the app, like, when should you actually return this response? What URL is the user going to visit? And this is where we now begin to create some URL configuration, some sort of setting to tell Django when a particular URL is visited, then this function should be run in order to return that particular HTTP response. So how to do that? Well, in order to do that, we're going to need to create a urls.py file for this particular app. So Django has one urls.py file that works for the entire project, but oftentimes we'll have each app contain its own urls.py file, just for the sake of separating things out into different places, such that if we have multiple different apps, each of which is doing something independent, we can have each of those individual apps have its own urls.py file, control what URLs are available for that particular app. So I'll go ahead and go into the hello directory, and I'll create a new file inside of the hello directory called urls.py. And what urls.py needs is it needs to define a variable called URL patterns, which will be a list of all of the allowable URLs that can be accessed for this particular app. And the way you create a URL is by first importing from django.urls import path. And let's create our first URL. I'll say path, and then the first argument here I'm going to give the empty string to mean no additional argument. And we'll see what that means in just a moment, meaning nothing at the end of the route. And then the second argument to path is what view should be rendered when this URL is visited. And so if I want to render my index view, recall that in views.py over here, I have this index function, then what I want to render when someone visits this URL, the empty URL, is going to be views.index. Views represents views.py, that file where I've defined all of my views. And index just so happens to be the name of the function that I want to call when someone visits this URL, for example. And then you can optionally provide a path with a string name to represent this URL. I'm going to give this a name of index. We'll see why this can be useful later on. But the idea is giving a name to a particular URL pattern makes it easy to reference it from other parts of the application. So later, when we might want to link to things or have forms that are submitting to different parts of the web application, giving a name to a path can be a useful tool. In order to use views, last line I need to add urls.py is to say from dot, in other words, from the current directory, go ahead and import views. Anytime I'm using a variable name like views, I'm using that name, I need to import it from somewhere. And it just so happens that views.py and urls.py are located in the same directory. So I can just say from dot import views to import all of that into this particular file. So this now is the urls.py file for this application. But the last step in order to get all of this working for the very first time is to go back into the lecture 3 directory and open up urls.py here. This is the urls.py file for the entire project, for all of the apps that might be contained within this project. And it just so happens that there's one path already given to us by default called admin, which runs a default Django application called the admin application. We'll see more about that in the next lecture. But for now, I'd like to add my own route here to say that I would like for a particular path to lead to not the admin app, but the hello app that I have just now created. So I'll go ahead and give this a path of hello. And what I'd like to do is say that after you've included the path hello, go ahead and include all of the URLs from the urls.py of my hello application. I basically like to link these two URL configuration files together. And so the command to do that is include hello.urls. Inside of the hello module, get at the urls file there. And that is now what I would like to add as a URL pattern. And in order to do this, I also need to import include, since I'm using include inside of URL patterns. So that was a lot of steps just to get things started. But just to get a high-level overview of how this is all working, I have a Django project called lecture 3. And inside of lecture 3, there's a URLs file. that decides what URLs I can access. I can access /admin, which takes me to the admin application, which is created by Django. You don't have to worry about that just yet. But now I've just added that you can go to /hello to go to the hello application. And when you do that, I'm telling Django to look at the urls.py inside of the hello directory to figure out what additional URLs I can get to from there. So this is one master urls.py file that might connect to multiple different other URL configurations that exist as well. Then inside of the urls.py for my app, for the hello app, I've said that when someone visits just the default route on this particular application, go ahead and just run the index function that is one of my views. So all that's to say, now that that is done, I should be able to go back into my terminal and run python manage.py run server to actually start up this web server. And now I can go back to this URL. But instead of just going to that default URL, I'll go ahead and go to that URL /hello. And when I go to /hello, what I see is hello world. So what was happening there is that I typed in a URL. That URL went to Django, and Django looked at that URL and looked at my urls.py file and said, you know, anytime something starts with /hello, that belongs to the hello app. And inside of our hello configuration, we said that when we go to the default route, we should run the index function, and the index function returns this hello world response. And now we can begin to change that response. We can begin to adjust what it is that views.py is actually doing. Right now it says hello world, but if I want to change it to just say like hello, for example, I can just edit it. Now say the index function just returns an HTTP response of hello, for example. And so now if I refresh this page, now it just says hello. So I can edit my files. When I do, Django notices that a change has been made, and it will re-update the server with my latest code, such that now I can visit /hello, and I can see that an HTTP response of hello is what ultimately comes back to me. So now let's take a look at the idea that in addition to just having one view inside of views.py, I can have as many views as I want. I can create additional functions that each return different responses. Maybe I'd like a route that says hello to me, for example. So let me define a new function that I'll call Brian that accepts a request argument. And this function is just going to return HTTP response hello Brian, for example. And now I need to associate this new view that I've created with a URL. So I'll go ahead and go back to urls.py inside of my hello directory. And so I have a default route represented by the empty string that loads the index function. But I can add to this. Just add to this list, add a new path, where if I type Brian into the URL instead, that will load the Brian function, and I'll go ahead and give that a name as well. So now, if I refresh the page, I'm still on just a /hello route, and that just displays hello, for example. But if I go to /Brian, for example, now I see hello Brian. I have two different URLs. One that is just /hello with nothing after it, which was that empty string, and one which was /hello with Brian following it, that loads a different view function that returns a different HTTP response. And so we could imagine continuing to do this. I might want a web application that has a number of different URLs that I can visit. So I could go ahead and add like a David function, for example, that returns an HTTP response of hello David. And then again, inside of my URL configuration, I would say, go ahead and give me another route called David that loads the David function. Each time I'm giving it a URL, so what comes after the /hello, I'm giving it a function to run, the David function inside of views.py, and giving it a name just to make it easier to reference a little bit later. And so now I have /hello/Brian, and now I have /hello/David, each of which displays a different HTTP response. So you can imagine starting to use this feature to begin to build a web application that has a number of different routes, that has different routes to do different things. And many web applications are parameterized by what it is that's actually in the URL. So for example, on Twitter, you can go to twitter.com/someone's username to see all of that user's tweets, for example. Or GitHub, a service we've taken a look at now, you can go to github.com/your GitHub username to be able to see all of the repositories for a particular user, for example. So if you think about how that might be implemented, if either of these services were using Django, they might have a urls.py file or something like it that is just defining a whole bunch of URLs and saying what route should be associated with them when someone visits that page. But you can imagine ultimately that this is probably going to start to get tedious. That if I want to say hello to anyone, if I want to not only support /hello/Brian and /David, but I also want to support arbitrary names like /Harry or /Ron or /Hermione, well then it would seem that I need to create a whole bunch of different functions, each of which says hello to a different person, and then create a whole bunch of different URLs to be able to do that as well. But it turns out that what I can do is create URL patterns that have placeholders, in effect, things that allow me to parameterize the path via certain path converters, so to speak. So what does that actually mean? Well, let's instead of creating functions that just say hello Brian and hello David, let me create a new function that's just called greet, for example, that also takes a request, but takes an additional parameter. It takes a parameter like someone's name, for example. And this greet function is going to return an HTTP response of hello, comma, and then I'll go ahead and plug in the name here. and I'll need to add an f to the beginning of the string to indicate that it's a formatted string. This is just Python syntax, to say that I would like to say hello, not just to anyone, but to whatever the value of the name variable happens to be. I'd like to substitute the name variable into that greet function. And then what I can do is inside of urls.py, I'll go ahead and add another path. But instead of saying a name like Brian or David or Harry, for example, here, I'm going to say, in angled brackets, stir::name. And when someone visits that route, let's go to the views.greet function, and the name for this route will be greet. And so what's going on here is we have a fundamentally different kind of path. Rather than prescribing exactly what the URL should look like nothing after the end of the route, or Brian at the end of the route, or David at the end of the route, this route here on line 7 is saying this route could be any string that we're going to give a variable name of name to, but you could replace name with something else entirely. And this could be any string. So it could be Brian or David, or it could be any other name. And when that happens, we'll call the greet function. And when that function is called, it will pass in this argument, this name, as a parameter to that function. So now I'll be able to create a custom route that allows me to specify any string and figure out how to deal with that appropriately. So now if I visit /hello/Harry, for example, not a route that I explicitly created, but that is a string, Harry is a string, I press return, it says hello Harry. I can go to /hello/Ron and say hello Ron, and /Hermione to see hello Hermione as well. And you know what, maybe just for good measure, I'd like to capitalize this name, like Hermione, for example. Well, the way to do that is that I can add arbitrary Python logic. It turns out that with any Python string, there's a function or method on that string called capitalize that I can say is just .capitalize. And if I can do it in Python, then Django allows me to incorporate it into the response that I'm giving back. So I'm now using Python to take the name, capitalize it, and use that in the response that gets sent back to the user. So now /Hermione returns hello Hermione with a capital H, likewise for hello Ron, likewise for hello Harry. I've now been able to add a route that takes an HTTP request as well as a parameter, that name, whatever was in the URL, and return an HTTP response that just says hello to that person. So these HTTP responses can be any HTML content. Right now we're just using text, but you can imagine adding lists or tables to this as well. But you might imagine that if I have to include an entire HTML page just inside these double quotes, that's going to get unwieldy very quickly. Very quickly we're going to find that there's a lot of HTML to just go in a single string inside of a Python program. And if we think back to the principles and the ideas that we've been looking at in this course so far, we've generally tried to separate out different parts of our application wherever possible. And there's a lot of value in that. One, in just keeping things clean. Two, in making sure that people are able to collaborate. If you want one person working on the Python logic and one person working on the HTML, you'd rather they not step on each other's toes as they're working. And so what we can do in Django as well is separate the response, the HTML, from the actual Python code here as well. And so the way we can do that is instead of returning an HTTP response, I can instead, let's say for this default route, instead of returning an HTTP response of hello, let me go ahead and render. And when I render something, I need to pass in the HTTP request, but I'll also pass in the name of a template. And I'll go ahead and call this template hello/index.html. So if I don't want to render just a string, but I want to render an entire HTML file, I can call this render function, pass in the request, but then also pass in the name of a template. And now all I need to do is create that template. So let me go ahead and inside of the hello directory, I'll create a new folder called templates. Inside of that templates, I'll create a folder called hello, because the template name here is hello/index.html. So I need to create a folder called hello, inside of which is a file called index.html. I could have just called it index.html without the hello, but the reason we often want to prefix our templates with a directory name is to so-called namespace them, to make sure that if we have multiple different index.html files in multiple different apps, to make sure they don't conflict with each other. So Django best practice is to use hello/index.html, or whatever your app name is, and inside of that hello directory, I'll then create a file called index.html. And this index.html can contain any HTML content, same as we've seen before. So I could add that doc type, the HTML tag, a title of hello, and maybe inside the body, I'll have an h1 that says hello world, for example. So I can have an entire HTML page just like this. And now, when I visit the default route of my web application, by going back into my web browser and just going to /hello, for example, now I see that HTML that I've defined inside of index.html. It's a big h1 that just says hello world. And it turns out that these HTML pages, these templates that I can render using Django, are parameterizable as well. Right? Maybe I want to implement hello/Hermione as some sort of HTML page, an HTML page that says hello, Hermione. And using HTML out of the box, you can't really do stuff like this. HTML is a markup language, not so much a programming language, which means it doesn't by default have support for things like a variable to represent someone's name. But using Django's ability to take an HTML page and treat it like a template that we can render, Django's added its own templating language, so to speak, on top of the existing HTML, and I can take advantage of that to be able to render an HTML page that actually has a variable inside of it, or a condition inside of it, or a loop inside of it, as we'll see in just a moment as well. So let's go ahead and go back to views.py. And the function that I would like to change is this greet function here, that right now is just returning an HTTP response, but I'd like to render an entire page, for example. So what might I render? Well, let's render a template called hello/greet.html. And then this render function can take an optional third argument, which is called the context. And the context is all of the information that I would like to provide to the template. All the variables, for example, that I want the template to have access to. And so one thing I might want my template to have access to, for instance, is something like a name. And so this is a Python dictionary, just a sequence of key-value pairs. And this name might be associated with what value. So name is the key. The value I want to be name.capitalize. And so what's going on here is that now, when I render this template hello/greet.html, I'm providing that template with some additional context, some additional information, as represented by this dictionary here, where I'm providing information with a key of name. I'm effectively giving this template access to a variable called name, and its value is whatever name.capitalize is equal to, where this name here is the argument to the function greet. So now I can return this template, and inside of greet.html, I can use this variable called name. So how do I go about doing that? Well, let's first create that greet.html file. So inside of the template/hello directory, I already have index.html. I'll go ahead and create a new file called greet.html. And inside of greet.html, I'll go ahead and write some HTML. And inside the body of the HTML, whereas before I might have said something like hello, world, I don't want to say hello to world. I just want to say hello to whoever the name is, whatever is contained inside of that variable called name. So how might I go about doing that? Well, what I can do is use these double curly braces. And double curly braces are part of the Django templating language that allows me to say, I would like to plug in the value of a variable into this particular position inside of my template. And so if I include the word name here, then what I'm saying here is that when you render this greet.html template, inside the body of the page, I would like for there to be an h1, a big heading, that just says hello, and then inside these double curly braces, I'm saying plug in the value of the variable name there. If name is Hermione, it's going to be hello Hermione. If it's Harry, it's going to be hello Harry. If it's David, it's going to be hello David. So let's go ahead and give this a try now. Now, when I go to /hello/Harry, for example, I now see a big h1 tag that says hello Harry. If I go to /hello/Ron, I see a big h1 that says hello, Ron. And the reason why all this is happening, the way we're getting to that final position, is because URLs says that when I have a URL that just is a string, like someone's name, we'll call the greet function. The greet function inside of views.py is taking the name as an argument, rendering the greet.html template, and passing in that name as part of the context, part of what the template has access to. And inside of greet.html, here's the actual HTML file. Here's where we then plug in the value of name. So it's a lot happening across a lot of different files. But the reason for all of these various different files is to help keep things separate, to have one file that is just responsible for URLs and directing people to what should happen when those URLs are clicked. Then we have one file, views.py, that is entirely responsible for deciding on this particular view what template should be rendered, what information should be passed in as context. And then I separately have a file for each of my HTML templates that are saying what does the page actually look like. And so if you start to begin to think about this separation of components inside of a web application, it can help to make the structure of a Django application a little bit clearer. So we've now been able to use the Django templating language to put variables inside of our HTML templates, to be able to create an infinite number of different routes where I can visit /hello/some name in order to display hello to that person's name. But the Django templating language is even more powerful than just that. There are a lot of additional features that the templating language is going to give us access to. And we'll take a look at a couple of those now. And to start, I'm going to introduce you to a website you may be familiar with. I consider it to be one of the simplest websites on the internet. It's a real website called isitchristmas.com. And if I visit isitchristmas.com and press return, here's what the website says. The website says, no, it is not Christmas. And you just have to take my word for it. If you visit this website on Christmas Day, you go to isitchristmas.com, it will instead say yes. And so this website is very simple. You might imagine that it's really just an HTML page that probably contains a big heading that in this case just says the word no, but on Christmas Day just says the word yes. Now, how might a page like this be implemented? Well, one way you could imagine is that on Christmas Day, whoever maintains the website goes into the HTML and changes no to yes, and then afterwards changes the yes back to a no. But we can be a little bit cleverer about this if we realize now that we have the ability to use Python logic, to be able to use logic like a condition, to be able to decide how a web page is ultimately going to be rendered. For instance, the condition might be something simple like, if today's date is Christmas, then render yes, else render no. And so we're going to use Django and take a look at some of the features of Django's templating syntax to be able to create a website like this. We're not going to create is it Christmas, we're going to create is it New Year's, that checks if the current date is January 1st or not. This is going to be a separate app. It's sort of distinct from our hello app. The hello app just says hello to people. The New Year app, for example, is just going to see whether or not it happens to be New Year's, for example. So I will now go ahead and create a new app. And I can do that by writing python manage.py, start app, and I'll call the app New Year, for example. I'd like to create a new app called New Year. I've now created that new app. If I type ls, you'll see that not only do I have a hello directory that represents the hello app, I now have this New Year directory that represents the fact that this is a new app called New Year. As with before, I'll need to go into settings.py inside of my project directory and add New Year as an installed app. This is now a new app that exists in my web application. So it, too, now needs to be a new installed app. What else do we need to do for new apps? Well, I need to go into urls.py for lecture 3. And just as before, I had a path saying when I go to /hello, then you should go to all the URLs for the hello app. Let me add a new path that says that if I go to my application /New Year, well, then you should go to all of the URLs for the New Year file. Go to New Year's.urls, representing the urls.py file inside of the New Year's app. Now, that file isn't given to us by default, so we need to create it. I need to go into my New Year folder and create a new file called urls.py. And inside of that file, I'll do from django.urls import path from .import views, and then define some URL patterns, same as before, where I'll just have a single path that loads the index function inside of views.py, and it has a name of index. So again, just mirroring the type of structure that we've already seen before in the hello app, this app is just going to have a single route, the empty route, that loads the index function. Now all it's left to do is to actually create that index function. So I go into views.py, and here now I'll define an index function that takes an HTTP request as an argument. And now inside of this index function, I would like to add some logic that checks whether or not it's January 1st. And so how might I go about doing that in Python? Well, it turns out that there is a date-time module in Python. You can learn about this just by reading up about its documentation to figure out how it works. And the date-time module gives me access to things about the date and time, for instance. And I can play around with the date-time module outside of Django just to get a feel for how it works. If I just type Python into the interpreter, into my command line rather, what I get is the Python interpreter that lets me just write Python code just to experiment and test and see what the result of running this Python code would be. So I can try like import datetime, for example, and let me create a new variable called now, which is datetime.datetime.now. It just so happens that inside of the datetime module is a function called datetime.now that gets the current date and time, for example. And so inside of now, I have access to variables like now.year, for example, which tells me the year, now.month, now.day. It gives me information about the year, the month, and the day of the current timestamp based on getting whatever the current time is right now. And given that I have this information, you can imagine us constructing a Boolean condition to check whether or not today is, in fact, the new year. And that condition might look like now.month equals 1, and now.day equals 1. And I can press return and see that, OK, the result of this condition is false. It is not true that both the month and the day are true, or are 1, rather. And so using that sort of condition, I can now take that and adapt it into my Django view that I'm using to try and render whether or not it's the new year or not. So how might I go about doing that? Well, what I'd like for my index function to do is return render a template. The template will be called newyear/index.html. And then what context would I like to provide to this template? What information, what variables do I want for this template to have access to? Well, I want it to have access to a variable that'll just be called new year. And in order to access that, I need access to the current date. So to do that, at the top of my file, I'll go ahead and import datetime. And inside of my index function, let me give myself a variable called now, which is equal to datetime.datetime.now. And this new year variable that I'm passing into my template will be equal to now.month equals 1, and now.day equals 1. So if it is the case that after I get the current date and time by running datetime.datetime.now, saving the result inside of this variable called now, if both the month and the day are equal to 1, then the value of this new year variable is going to be true when the template gets access to it. Otherwise, as it is the case today, and on most days, the value of that variable is going to be false. Now all that remains for us to do is to actually create this template, newyear/index.html, and have that template somehow use this new year variable in some interesting or meaningful way. So how do we do that? Well, if you recall what we did with the hello application, when we want a template, then inside of our application, this new year app, we'll need a new folder that we'll call templates, inside of which I'll create a new folder called new year. And inside of that, I'll create a new file that will be called index.html. Here will be the index.html file for this New Year application. The structure will be very similar. I'll give it a title of Is It New Year's? And inside the body, now here's where the interesting logic is. Sometimes I might want a big H1 that says yes. Other times I might want a big H1 that says no. And what I need to do is conditionally decide when to say yes and when to say no. And inside Django's templating language, and again, you'd only know this by reading Django's documentation, just as we used double curly braces to say plug in the value of a variable here, the syntax for logic inside of a Django template, like conditions, is curly braced %sign. So we use curly brace %sign, some logical statement, and then %sign curly brace to include any kind of logic. And the logic in this case is an if statement. And this is very Python-like. We'll say if new year. New year is the name of that variable that I passed into this template. And if it is a new year, then I want to display an H1 that just says yes. And then else, also inside of curly braces and %signs, I want a big H1 that just says no. So if it's the new year, then yes, else no. And then Django also requires me to give an end if tag to say this is the end of the if statement. Unlike Python itself that uses indentation to denote when the if statement is beginning and ending, in Django the indentation is optional inside of the template, but in order to distinguish when the if statement is happening from when the if statement is over, we need this end if tag at the very end. So this here is a condition inside of our Django template. We're saying if a particular variable is true, then render this in the HTML, and else render something else. If it's the new year, say yes, it's the new year. Otherwise, say no, it is not the new year. So we can try this out. Right now, we're on the route /hello/ron. If I instead not go to /hello, but go to /new year, for example, this site can't be reached. OK, so why did that happen? 127.0.0.1 refused to connect. So what must be happening is for some reason my web server isn't running. And it turns out that in order to create the new application, I had stopped my web server. And so if ever that happens, to start it up again, we can just rerun python manage.py run server to say I would like to now start up this web application again. And all right, it looks like now I have another error. There's some sort of syntax error. And the syntax error is in new year /views.py. So let me go ahead and go back into views.py and see if I can spot where the syntax error is. And all right, it looks like render.
哪里痛？
屁股骨盆都要炸裂了。
这就是真工作。
对，真的，快睡吧。